Okay, it's Robert Wiesenfeld, AK6L here. Another update on my 6J5 oscillator. Good news to report. I've cured, it seems like, most of the thermal drift. The big changes I made were moving the coil away from, you can see it right here, away from the tube, which was causing a lot of heating problems apparently, but also changing out the tap coupling capacitor here for a polystyrene instead of a silver mica. The silver mica was right up in this screw terminal, very close to the tube, and I think that was causing a lot of heating effects. Can't get a very good view on that polystyrene cap there. You can kind of see it. It's right there. Anyway, so the oscillator is running right now. I have some other problems. It appears to be squegging or something along those lines. I'll show you here on the scope. So this is at its max frequency. I'll change the horizontal time base here so we can get a little better view of the waveform. As you can see, that's a kind of a gnarly waveform. There are a lot of harmonics in that. Let's go over to the spectrum analyzer. So here you can see all the harmonics. The horizontal line there says that those harmonics are down at about negative 47.2 dB. That's just a relative measurement because what I'm using to couple this to the spectrum analyzer is this little 4-turn AWG26 link on a BNC connector, and then that's connected to the 50 ohm port on my spectrum analyzer. So, because I don't know exactly how closely that's coupled and so on, I don't know exactly what the power level is there. But relative to the fundamental, those are down at negative 47.2. The fundamental is up at about negative 20. So it's about 27 dB down in the fundamental. Not very good, but there's no filter on this, so not very surprising. Not sure what is causing this to be so bad at the top end of the frequency when if I shift this down in frequency, if I give it more capacitance, you'll see in a second here, the waveform cleans up considerably, and we don't get as many harmonics on the spectrum analyzer. So change that down to the maximum capacitance, and see if I can focus on this. Change the time base. So as you can see, the amplitude is significantly lower. This is less than a volt. I'm taking this from the cathode, right at the DC resistor, the bias resistor on the cathode there. But change the volts per div here, and you can see that looks like a pretty clean sine wave. And if we look at the spectrum analyzer, I'll have to change some settings on here so we can get a good view of this. Let's see. Turn the marker back on, find our signal, and there we go. So this is only 1 megahertz span. I'll make this, let's make this about 5 megahertz. So this is 1.89 megahertz or so. So I should see something at about, let's see, what would that be? Let's call it 1.9 megahertz. I should see something around 38 or 3.8 megahertz if there were a first harmonic there. And as you can see, I've got the marker around 3.8 megahertz, and I don't see anything there. So lower down in its frequency range for this oscillator, it seems pretty clean. All the rest of these that you're seeing here, these are actually AM broadcast stations being picked up by my totally untuned pickup coil here. The capacitance across this is just going to be whatever's in the coax cable itself, I guess. So anyway, more progress. I am pleased to see that it's pretty clean down here at the bottom of its range. Other things to report, I'm a little disturbed by the fact that I can actually get the oscillation in this to stop if I play around with the capacitance on the air variable a bit. I can actually get the oscillation to stop at some point. I have had a couple of times where I've turned it on and it hasn't actually started by itself. Not sure what's up with that. So Anyway, work continues, but thought you would all enjoy an update. Once again, Robert Liesenfeld, AK6L, thanks for watching.